So what I just said is when we talk about stock valuation, it's really important that you realize we're looking, and you always have to think about this in this course and in valuation of assets. You have to think about whose perspective and where they stand. So the person who's looking at purchasing stock, valuing the stock, they're looking at it as though they don't have stock right now. Okay. So as a prospective investor, you have to wait. If you purchase stock now, you have to wait a period. And 21 days is a natural waiting time to be able to be entitled to stock. Okay. And this creates a little bit of stability into the system that you can't just jump in when the stock is going up in value. You're going to have to wait. All right. And, or you predict it's going up with the assumptions and announcements that happen from the, that come from the firm, the corporation. All right, so where was I? G-star. Okay, so I'm gonna get the file blank. There's two problems on this document. So I would consider these a little more challenging. You know, the whole test is not going to be a bunch of challenging problems. I'll put something or one or two problems challenging. You're going to have 3 hours to write the test. You're going to have 3 hours. So how's the sound, by the way? Am I sounding okay? Because I never did check the sound.
Yeah, you sound right.
Okay, let me do a test, okay? Does it sound better? Does this sound better or worse or the same?
It sounds worse because of the echo.
Okay, so this is better. Okay. All right. So gain is low. I don't know much about sound technology, but I'm learning. All right. So YouTube is helpful. I've learned a lot of YouTube videos. All right. So here's the problem. And like I said, in the test, I'm going to probably put for that amount of time, some problems that are, well, I want to make it multiple choice. The test should be multiple choice. And I'll be surprised if I change my mind, but it's going to be multiple choice. However, write on the sheets of paper you're given, write out your full answer, okay, your solution to the problem, because I will look at that. If there's a conflict about interpretation, I can look at that for you. And you're going to submit both your multiple choice selections, your documentation of your answer, and your formula sheet. You're going to give them to me. All right. Remember, your formula sheet has to be in your own handwriting. It can't be a photocopy, it has to be yours. And it should be all formulas in there. It shouldn't be exercises or practice or copies of the notes. It should be just formulas. Okay. The other thing I said I would let you bring is a copy of the lecture notes, but just the printed notes, no extra writing on them, nothing like that, just the printed slides. And I put on the platform Moodle slides on 2 slides on a page, so that it'll limit the number of pages you have to print. Right, so I'll send an email with those details so people are aware that they can do that. All right, so let's look at this. Let me see about projecting this, how I can share. Should be able to share my iPad as is. I don't see it though. It's connected, but sometimes it loses. No. Weird. Do it again. Sometimes it's a matter of which outlet I plug it into. Just a second. That didn't work. Okay. What do you guys see right now? This is annoying.
We don't see anything. We've seen has started screen sharing.
I don't know. It's asking me to trust. When prompted, select trust, and I can't do it. So let me stop that one more time. Okay. This is so stupid. Okay, so I'm just gonna do, I don't know what this is. Why is this here? Stop share. Okay, one more time. I'm gonna just have to do it with what is the problem? Let me see. So I hate when I record and then this stuff gets recorded. Troubleshooting. Okay, you can see? No, you can't see. Okay, so let me get out for a second. Okay, so once I go onto the iPad, doing it by a projection using AirPlay, I cannot see the chat. So you're going to have to tell me, you have to speak up, okay? If you want me to stop or you have questions, all right, you have to talk to me. Or it's not gonna work. Okay, so you see the pantalla?
Yeah, we see it.
Good. An investor has just paid $141.75. So this is the price now for the purchase of one share of UMB Corp stock. UMB just paid $7 dividend per share. Annual dividends paid at the end of the first, second, and third years will grow at 10% per annum and then grow at a constant rate of G star forever. All right, so let's try and make a timeline to see all this in one illustration. So now the price, I can call it PV0 or price, is 141.75 for the purchase of one share of UMB corporate stock. UMB just paid a $9 dividend. So the dividend at time zero was $9. So I'm going to put that information here. Annual dividends paid at the end of the first, second, and third. So even this is an assumption, right? That payments are at the end of the period. You assume that unless you're told otherwise, all right? So dividends paid at the end of the first, second, and third years will grow at 10%. So G is 10% here. And then it grows at G star forever. All right, so what you have is the price now, the dividend now, which will help you calculate the dividend next period. That's why you want this information, but this does not go into the valuation, the $9, okay? Because we're not entitled to that if we purchase now. This is the current price. So this price, assuming rational investors and assuming perfect information, this has already valued in the 10% per 3 periods and the G star. Okay, so this has all the information captured. So we're going to use this as well. But to find G star has been used and is part of a formula that computes to be 141.75. So what we're going to do is look at what the cash flows will be at the end of each period. So this one will be G 1.1, right? I said G, 9 times 1.1. And then 9 times 1.1 squared at the end of year 2. And 9 times 1.1 cubed at the end of year 3. And then by the end of year 4, what will it be?
And 9 times 1.1 to the power of 4.
Okay, and is that correct? Wait a second. Is that correct? You're close. You're very close, but this is 3, but then it changes to G star. So you have to make not 1.1, but 1 plus G star. So it's not this, but you were close. You have to continue growing, but you're growing at the new rate now. So this is not hard. This part here, this goes on and on. This part, we can call this part something. Let me use a color. So cash flows beginning one period from here can be valued using the growing perpetuity formula. Okay, so let's get this so we feel good. All right, so this will get you half your points. What would be the value of at time 3 of cash flows starting with this as your C1? Obviously it's C4, but for the purpose of the formula, it's like your C1, one period from now. Okay, so who wants to give me a formula? So, okay, give me the formula from the formula sheet. What would it be? Anybody?
It will be C1 over I minus G.
Great. All right, so now let's put the numbers in. So C1 is, we agree it's this, one period from 3 is the 4th, so it's this here. So that would be the C1. And again, I'm going to use quotes because it's not really C1, right? It's supposed to be one period. No, actually, I'll put the number in. We should put C4 because it's one period after 3. So one period from now, that was the rule. So that's going to be there. And then I is 10%, right? And G, which G should I use? It's G star. Okay, so the other G just helped us find the value before a period of G star. So put all that together and give me a number. C4 is this whole thing here. You're going to have the 1 plus G. Don't forget about that. And then this is 10 and this is G star. So don't let it bother you that we don't know what G star is. It's going to be, we're going to find it. So again, this is a little more complex than all the problems I'm going to give you, but you could get a problem like this on the test, right? Should be able to do this, some practice, but the whole test will not be G star questions. So we don't know PV3. We'll just leave that. We don't know that. We know $9, 1.13, 1 plus G star divided by 0.1 minus G star. That's what we have so far. Does anybody disagree or anybody have a question about where I get that from?
My question is, why is it called PV3?
Because it's one period before the next cash flow. So we always value cash flows starting one period before. That's why in all the formulas, I have PV0 and then the first cash flow is C1 for that difference. Okay, so you always have to be, if I'm not starting at 0, then I still have to use the same principle. The first initial cash flow is one period from now. So that's my C1 for this part. This would be like my C1, one period from PP3. Did I answer your question?
Yeah, so C1 here is C4, right?
Exactly, yeah. I put quotes to say it's like the C1 that we're used to, but we're somewhere else in the timeline, so we have to modify. It's basic, the rule's still there. One period before is the valuation. Yeah.
Okay, now I understand. Thank you.
Good. I think I put it at the platform. I put the formulas there and I might have put the general formulas. Sometimes that confuses students. I just leave the first list of formulas so that, but you should be able to operate or function with those formulas anywhere on the timeline. You just have to remember that rule. One period before is the valuation of the asset. Now, you could have other formulas in other books or other teachers that teach you different formulas, but these are pretty standard that we value one period before. You need to know what these formulas do and what they don't do, right? Okay, because of those sorts of limitations or the structure of the formula, we can do this with this amount here. Now, so this was our first cash flow for this amount, but that leaves 1, 2, 3 more cash flows. Now 9 is out, right? The first 9, because we don't get that. We're not entitled to that. That's not included here in this valuation. So what we need to do next is, well, we have 2 things to do. We need to value these 3. And we need to take the value of these 3 at time 0. And we need to take the value of this PV3 at time 0. So we have 2 more things to do. And we need to equate those to this. So I can call this part A. I don't know if that helps or if it confuses you, but okay, I'll do it in colors. So this is the blue part. And this part I'll do in, I don't know, all the other colors are hard to see. I'll just stay with the black. Okay, so this is a different color. Oh, maybe, let's see if green is any good or purple. Let's do purple. The colors are too bright. Let's try green. If anybody has problems with seeing green, let me know. So I'm going to use colors. And what we have, so tell me what we're going to do with these 3 here. This one, and this one. I want to calculate PV0 in green. What will it be? You can tell me in words and then we can do the numbers. What would we call that? Just so you see, this one, this one, this one. Ignore everything else on the page. Just look at the green. What is that? What is that stream of cash flows called?
Dividends.
Okay, they're called dividends, but what the stream of cash flows though? What name do we give to that pattern from the formulas? What name? So that you can identify the formula. How do you value that? This is-
Growth.
Okay, excellent. So it's actually growth, but it's an annuity with growth, right? So go to the annuity, because it's an annuity because there's only 3 of them. It's annuity with growth. Now, it's only 3. So let's calculate it, or let's put the formula down. I'll give you a moment to look at that and look back at the formulas and see if you can write it down. So we've divided the future cash flows into green and blue. And right now we're looking at the first 3 that are the annuity with growth. Look at the formula and put in these values. So this one, the first one would be C1, this whole thing here. This will be our C1. Cash flow 1 period from now, right? So this would be like my C1. Let's write out the annuity with growth formula. So it's C1 over I minus G. Now, for 3 values, we have to do quite a bit using a very long formula. So this might be the confusing part, but that's what we have to do. You could discount it with the net present value rule, but you can't really, well, I guess you can. You could calculate each one and put it into NPV. That's another way, but this is much more sophisticated, let's say. The hardest part is figuring out the C1. Really, that's it. If you can see C1 is 1 period from the valuation. If you can see it, you're on your way. Obviously, you have to know which formula to use too. So but I'm not going to call that the hard part. The hard part is drawing this timeline, identifying the C1 and the 2 parts. There might be even problems with 3 parts, but I might hold off on those. I will probably hold off on those for the first step. Okay, you should be able to do something like this, but again, the whole test won't be this. If anybody's in Teams, please go to the Zoom. I can't see. I should check with my cell phone. Okay, when you are, okay, what I'm going to do is leave that and ask you to try and calculate that on your own. You do have the clave, but I recommend not looking at the clave. Just try and calculate that on your own. So we are recording. Okay, whoever has the opportunity, give me a number, give me some numbers, give me what you've got for this, tell me, and then I will calculate it. Let me know if you have any trouble reading green, because it's kind of light. They should come up with really good colors for the computer.
I have a question.
Yes.
You probably mentioned this before, but I just don't remember, or I just can't visualize it. But where does the 1.1 come from? Like when making the timeline?
Uh,
Like in the
so the growth rate is 10%. So that's G. The effective rate is 10%. So 1.1 is the 10%. It's 1 plus I, right? Oh, no, this is 1 plus G, sorry. So I'll put a 0 on it so you can see it better. But I'm glad you asked me. You see that now?
oh, okay, yeah.
Yeah,
Okay.
I know it makes a difference. It's very confusing. Okay, there. Okay. Yeah, I usually try and do that, but that's where it comes from. 1.1 looks very different than 1.10. I agree. Anybody? Give me a number for the green. Or do you want to build the formula together?
I assume in C1 it would be 9.9 and in the interest the 10% and in the growth the same 10%, if I'm correct.
Yeah. What is the problem then that you see? What's the problem? So what I'm showing you is that this is precisely the situation where we cannot use this formula. If you look at the formula sheet, I cannot be equal to G. So what do we do if I is equal to G? So I was telling you this is a more sophisticated way to do it, but we violate this condition. The formula doesn't work. Does it mean that the answer is 0, or does it mean the answer is unknown? Or can we solve this simply by using the NPV?
We can solve it by using the MPV.
Very good. Okay, so let's before we do that, let me show you something, that this actually simplifies again, but you need to know that it's happening, right? You need to be aware. So this formula here, the growing annuity formula, does not apply when I is equal to G. So you need another way. You can use the NPV, you could calculate each one. You have to be careful about keeping the decimal places, right? To get the same exact answer as I do. But what I want to do is I'm going to take this with me. No, I don't really want that. Hold on. I'm going to take this part. I'm going to take this part. So that's the timeline. So that's the timeline. But we have the situation that I is equal to G. So instead, we're going to discount these separately. And I have an example in the notes, and I'm pretty sure I discussed it in the video. I need to discount this one. So using the, you know what I'll do is I'll write 1 plus I so it's less confusing. So I would discount this one period, right? I would discount this one 2 periods, right? Because it's in period 2. And I would discount this one 3 periods. But what happens? Since I equals G, these cancel, right? These cancel and these cancel. So this is actually easier than ever if you recognize what it is. It's just, the answer is just 9 times 3. It's $27. Please let me know if that's confusing.
Okay, so my question is, since, okay, so if I is equal to G, obviously, which is 10%, and you add it is 10% plus 1, which is the growth formula. So when you have I equals is cannot be equal to G, so you have to just multiply it by 3 since we only calculated 3 periods, right?
Exactly. So what happens is the growth offsets the time value of money effect. Each time, bang, bang, bang. So it's just $9 from the perspective of today, 9 times 3. In the notes, I have that the growth starts in period 1 to period 2. So it's actually just 9. So the answer there is a slightly different because each one still, like here, I canceled exactly G and I, G and I, G and I. In the notes, I have that there's still a discount factor underneath. So it's like 9 times 3 divided by 1 plus 1. Anyway, you can look at that. It's just slightly different. So you don't have to memorize this. You can just do a quick reminder for yourself to see that the answer here for this green, so the green part, PV0, is just equal to 9 times 3 is $27. So that's where the 27 comes from.
That's in where the
Say it again.
that's always gonna happen in these type of cases, correct?
If you have an annuity and I equals G, yes. If you have an annuity and I equals G and the growth starts immediately, it'll be just 9 times 3. If the growth doesn't start immediately, it'll be 9 times 3 divided by 1 plus 1. I mean, 1.1. It'll just be one discount factor because the growth didn't offset erosion yet. So you have 1 period of discounting. You'll understand if you look at the notes, if you look back. It was at the very end of annuity with growth that I show you that. Okay, so you use the formulas to their limit, right? When you can't use them, you have to find other ways. This is one way. 1 second, okay? I have to just take a call. I'm so sorry. It's Friday and people don't think I'm working or teaching. Okay, so where was I? All right, so everyone's accepted the $27. You're okay with it?
Yes.
Okay, so let's go back and put it in. So this was just to show you the hard lesson that the annuity with growth has its limits. This cannot happen. But the advantage is it's very simple. We don't have to plug in this huge formula. It's actually very simple. So, and it's because the growth offsets the time value of money effect and erosion of the dollar. So that's actually a good thing. All right, so we have that this whole thing, I'm gonna erase it just because I'm running out of space. You guys can take a picture or make a note. Uh-oh, annuity with growth doesn't work, even though that's what I would call that stream of cash flows. So this is just going to be $27. Okay, so we have a green part, we have a blue part. And if it helps you, if colors help you, bring colored pens to class next week. And so what do we do now? We have the value here at time 0. All we need to do is discount this plus 27 equals this. Do you see that now? Then it's just algebra. Then all we have to worry about is algebra. So I'm going to put everything in black. It's 141.75 equals 27 plus. So I'm going to rewrite this. I'll put the discount factor. So I have to discount with a factor of 10% for how many periods? 3. And I know that because of this, right? And then I just rewrite this 9 1.13 1 plus G star. And you know what I'm going to do is leave it to you to try and solve it. And I'll wait here. So you want to simplify. Look how this simplifies. Let's simplify it a bit. You see that this cancels with this. If you know, with the algebra, you can put those numbers together, correct? So subtract 27 from both sides. And then you got to do some cross multiplying with it. So I'll leave it to you. Do it, try it for a few minutes and let me know if anyone gets it. You do have the clave, but try not to look. See if you can solve G. Be careful that some numbers, I mean, this is a 9, not a G. The G stars are here. So from here, this is not finance anymore, right? It's just algebra. It's not exactly easy algebra. It's a little bit complicated, but you can do it. I'm going to just put everything on one page in case somebody prefers to take a screenshot of everything. It's all there. This is very small, but it's there. See if I can make the rest smaller.
professor.
Yes. Yes.
Somebody in the chat asked how many questions is the exam going to be in the chat.
I think it's gonna be 6. But they're gonna be parts on some of them. Maybe. I haven't made it yet. I try
Is
not
it
to
going
bias.
to be
Mhm.
is it going to be the first chapter, like the first unit, and the second unit like half and half, or
No, it's gonna be
should be
it's gonna be like the first unit, but with interest rate conversions. So it's gonna be you know, I'm not gonna make it too hard, like I say, but I have to have some challenging problems. So think about it like somewhere in between, like you're saying, half and half, somewhere in between the two, because it's still early in the semester, but you should be practicing. You should be confident with all the problems I've given you. The test prep are just to stretch your muscles. All right. They're going to be harder than I'm going to give you. So don't let the test prep freak you out. That's just, you can ask me those questions. I can work with you on those. If you want to meet again before next week, we can meet again. I can make a time like this one, and we can go through those problems too. But the most important are the documents that I've given you and that you understand every problem and you're comfortable with them. Okay.
And what's the runtime of the exam?
You can stay 3 hours if you want, but you should be able to finish in an hour and a half.
Okay, thank you.
I give
so
you
the exam is it going to be like I've seen the videos you've in Moodle?
yeah.
Is it gonna be like the examples that you have given, or is it gonna be like harder?
Yeah, it'll be like the examples that in these notes, in the documents. Yeah, in the documents in Moodle, like those. And then,
And we
like I
can take the formulas too.
and you can take the formulas and you can put them on a paper, on a sheet of paper, and bring that with you.
Okay, thank you.
Yeah, but no examples, just the formula. Okay. Like on the first document, the formula sheet, you can copy that out. It has to be in your own handwriting. Cannot be a photocopy. Has to be you writing it down. So this way I'm forcing you to practice writing down, because some students just read these documents and they think they understand, but you have to write, you know, you have to process by yourself and a matter of writing. So I'm asking that you prepare your formula sheet in your own handwriting. And then I will take it when I take your test, I will also take the formula sheet. I will give it back to you at the next test, or you can take a picture of it so you have a copy and you can reproduce it. But you're going to submit it to me with the test.
I had a question regarding, because when I was practicing, I kind of noticed that it was hard for me to identify what type of like formula I should use, because sometimes there's like the one with growth or not with growth, or no, sometimes it's more than one that you can
Yeah, but that's
use.
okay. Yeah, it's a
And I just wanted to know like what are the key signs to determine which formula I should use in a given problem.
You make a timeline and you try and match your timeline with the timeline on the formula sheet. You guys can write the timelines with the formulas if that helps you, but you need to match. So my recommendation is draw what you read in the problem, draw it on a timeline. That way I know how you read it and I can compensate you if you read it wrong or you read it different from me. And I can, you know, if I respect the way you've read it, that it's rational, you know. So if you communicate to me using the timeline, it'll also help you to match the timeline on your page with the timeline on the formula sheet. So that's how you will know. The fact that there's an extra term here and it's growing and growing and growing, I mean, that's a growth. The fact that I put 3 dots, it's perpetuity, but the growth change, you know, there's 2 parts. When their growth changes, there are 2 parts, and you have to do a 2-part problem. Sometimes the growth changes and there's 3 parts, but I won't give you 3 parts for this test. It's too demanding. I hope that answers your question. So that's what I recommend. I mean, we can continue doing problems, But basically, if you make a timeline and you match to the picture, to the images of the formula sheet, let me see if I bring up a formula sheet. Oh, I have to go here. Sometimes I clear out things and I don't have it here. 1 minute. I recommend every time you draw a timeline, try and draw it so it looks like, you know, one of these. Right, so this one is annuity that stops. This is a perpetuity that continues 1 period from now. So you got to get used to these timelines to see which formula matches, which problems match with which formulas. Honest to God, there are just 2 formulas on here and then just mathematics, because the 2 formulas are the perpetuity and the regular time value of money. All these formulas come from the perpetuity and the regular time value of money. They're all combinations of these 2 formulas. So we get creative, and I write down these formulas as examples, but you could have different variations of these as well. But these seem to be the most, these go a long way. But remember the limitations, annuity with growth, all of them require the first cash flow 1 period from the valuation, from the pricing. 1
Oh,
period.
okay. Well, thank you. I think I'm a little bit clear now.
Oh, good. Okay. So work with this page in the next week. Just keep this by you, by your bedside. And try and draw it. If you sit down and you try and reproduce these formulas in the timeline, even that will be enough. If any of you are athletes or musicians, you have to practice, right? So you just repeat the same kind of tedious movements or the tedious things to get through the hump. And that one would be to recopy this formula sheet to practice. This timeline is like this. Pay attention, while you're doing it, and realize the differences and the similarities, and even this condition here. Also, there's a condition for growing annuity as well. Remember, growing perpetuity, sorry, that I has to be greater than G. So there's these 2 conditions on those problems. All right, so hopefully that helps. The challenge you have right now is you just have to focus, okay? I'm not going to give you any more material. And I'm going to encourage you, like, the test prep is harder than what you're going to get on the test. So if you are bored, or if you've done all these problems and you're successful with all these problems, go into the test prep to challenge yourself. I put the solutions up, right? The answers. I didn't put the solutions. I put the answers on the test prep. Is that correct? So you have the test prep and you have the test prep answers only. Is that correct? Is that what you said?
Yeah, I think so, yeah.
Yeah, so I put the answers only so that then if you don't get it and you want me to show you how I got my answer, I can meet with you, or we can go over it. You can send me your problem, you can text it to me, and I can look at it, or email me. And you guys can speak to me in Spanish. I understand Spanish. I just don't sound sophisticated in Spanish, so I don't speak Spanish with my students because they giggle. Students giggle when I speak Spanish, so it's distracting. Okay, so feel comfortable to contact me this week, even after, about any questions you have. Should we solve the last problem? We'll finish with that and go on to
Yeah,
the
if possible, like after finishing this problem, can you, because I had a doubts regarding the second unit. I'm a little bit confused on I suppose the general idea would be the interest conversions, but I'm just confused on the unit 2 and overall.
Yeah, it's basically the same problems, but with more realism, right? The first unit are problems that are very basic. They're very theoretical. They're not practical. And the second unit are more practical, more realistic valuations using interest rate conversions, because we have to deal with those in real life. So yeah, we can go to that. We have some time. Let me check something. Well, anyway, did anybody solve this by themselves? Or you want, let me finish this and then we're going to take a break, just a couple minute break, because I need to check something.
Okay, I tried to solve it, Professor.
Uh-huh. How'd it go?
Okay, so first thing I canceled 1.1 to the power of 3 on both sides. Then I canceled G star and G star since they both can cancel out. Or is that wrong?
Yeah, you can't cancel these because then you don't have, yeah, no, this is 1 plus and this is 0.1 minus, so they don't cancel. But yes, you were very ambitious to cancel them. Then you don't have anything. But no, they stay. But what you can do is, okay, let me simplify this. Let me bring this up to another page. I'm gonna bring another page. Hopefully, I have not made any errors in this. Let me clean this up a little bit. All right, so this would be what I would do next. I would take 141.75 minus 27. And that would equal 9, 1 plus G star and 0.1, well, it's 10% minus G star. And then this simplifies to 114.75, right? And then 9, 1 plus G star. I'll go step by step. I won't rush. Now I'm going to cross multiply. I'm going to multiply both sides by 0.1 minus G star. So 0.1 minus G star times 114.75 equals 9, 1 plus G star. And if I haven't made any mistakes, we're getting close. Have I made any, does it look like I've done anything wrong here? Sorry, I'm asking you. It's just, I don't want to keep answering the wrong set of lines of code here, lines of solution. So then this one would be 114.75 minus 114.75 G star equals 9 plus 9 G star. Now we're going to add 114.75 G star to each side and subtract 9 from each side. And you get 2,475 equals 114.75 plus 9 G star, because they're both G stars. So G star is equal to, because what is this number here? I really hope I didn't make a mistake, but it's possible. 4.75 plus 9. So 123.75. So what I'm going to do is solve G star as 2,475 divided by 123.75. How does that look? And it's a nice round 2%. Is it possible? It is. So that's algebra. It's a long page of algebra, but you guys can do algebra. You got this far, you can do algebra. Just got to take it easy. So this is the kind of thing I mean that I want you to write your answer so I can see where you went wrong. Let's say you had the whole problem right for 5 points, but you couldn't solve the algebra. Now, you should be able to do this algebra, but if you can, then I can give you like 3.5 or 4 out of 5, depending how well your algebra, well, how well you did with the algebra. Some students who don't want to do the algebra will just guess and put numbers in there, but that can be complicated because this is really long. But it's reassuring when you get a nice round number. It's like, wow, I must have done this right, because what's the chance that all that complexity resulted in a very simple number? Okay, so that took a lot of time. So clearly I can't let your test be all problems like that. I wouldn't do that to you. Any other questions?
I mean, if we can discuss the interest conversions.
Yeah. Is everybody okay with that? Let's see, let me get, tell me if you've done this and I can close this. Let me know if I can close this, but you have to verbalize it, right? Because I can't see the participants.
Yeah, so you can close it.
Okay. Okay, so would you like me to discuss interest rate conversions, or would you like me just to do interest rate conversion problems, like in the test prep thing?
Well, I guess the test prep thing, because I mean I'll understand when you do it.
Exactly, exactly. Okay, so give me a minute. I'm going to get out of here for a second. Okay, and thank you for coming, because this is going to be shared with the class and they can benefit from your participation. So I have to find the test prep. I don't know why it's not on my iPad. I like the test prep problems, like they're for students who are bored with the other problems, or students who really want to exercise their understanding. But again, the test won't be that hard. This first one anyway. So I teach this class, I teach this topic, corporate finance, in the MBA in the 4th, 5th year of the finance concentration. And I'm also teaching FINA 3106. So there's different levels. I have all levels of material. So you guys are in between. But I'd say, having said that, your textbook is still considered like an MBA textbook. So I have to just steer a little short of that. But if you do well in this class, you should be confident that you can take an MBA finance class and do well. if that's any consolation. I mean, you'll still learn new things, but you should do well in 75, 80% of it. I'm almost there. Okay, I'm just going to set up the first few problems. Okay, so the first few problems of the test prep are really just making the conversion, but you need to know which conversion to make as well, right? So we'll do a few of these and then we'll go into the other problems. I'm almost there, sorry. I'm just getting ready. Okay, so I'm going to use the symbols that I taught you. You may have learned how to do this before, but with different kind of symbols and things. And if you really understand what you're doing, it won't matter that you do it my way or another way. But if you don't understand, it can be confusing. So I would recommend just do it my way. And then once you understand things, you can look and try and match it with what you've learned before. Okay. I mean, I studied this kind of finance math for many years, and I didn't understand it completely until I learned it this way. So that's why I'm sharing it with you. I think it's quite thorough and brilliant and allows you to do it. It's just a very powerful tool. Allows you to do very complex problems. All right, I'm sharing. Oh, I share. Oops, I was going to share in Teams. Okay, back to Zoom. share my desktop. Okay, so the first question on the test prep. Oh, I erased too much. Okay, so I'll have to write out the first question.
I can only see, I guess this is the computer screen, not the iPad.
It disconnected. Let's do that again. Or
Okay, now
I disconnected it, but I didn't realize somehow. Okay, so there. All right, so the first one is it says semi-annual rate, compounded semi-annually, right? Semi-annual rate. Compounded semi-annually. Okay, let me write that a little cleaner so it looks the same. So what you have is they're asking you for a semi-annual rate, compounded semi-annual rate, semi-annually. So because the compounding interval is the same as the interval over which we're stating the rate, when they're the same, you're being asked to find what's called an effective rate of interest. This is actually what you pay over that period. And surprisingly, there are rates that are quoted or stated that are not reflecting exactly what you pay per dollar over that period. So what we're looking for is an effective period rate of, I put a quarter, I meant 1/2. Okay, semi-annual. So this subscript here is a fraction of a year. Or let's say in years. That's what I'm going to say. It's in years. Okay, so you have to put it in years, so it's half a year. That's what this subscript is. So I want to find that, but what am I given? I'm given information about the effective annual interest rate. Well, that's just EAR. That's the notation I use for that. That's the effective annual interest rate. I could also call that the effective period rate over a year. So it matches with what I'm trying to do here. So this is half a year. This is 1 year. And then you think about the growth or the time value of money idea. And basically you want to match what you're given with what you need or what you want. So you're given the effective annual rate or EPR1. So I don't know which one makes you more comfortable. Let's use EAR. Let's use EAR. Because I think I use that more often. And what I need is EPR 1/2. Now tell me which one is a smaller number. If I'm trying to find the equivalent rate, which one is a smaller number? Half a year or 1 whole year of interest?
maybe half a year.
Right, it's smaller. And in fact, 2 periods of interest is the same. 2 periods of half-year interest is the same as 1 year of interest. That's the relationship between the two. So each time I do this, I don't have to memorize any formulas really. I just need to understand how these relate. And this is the relationship that 2 half years that are effective make 1 whole year. But when I say 2, I put the 2 in the power because we're compounding, right? Compounding. So that goes up here. They're like factors of accumulation, factors of growth, factors. So now I put in the numbers that I know. So I know this is 1.15. And that should be equal to, I won't put brackets, is equal to 1 plus EPR 1/2. So 2 of these small ones make the big one. So what I have to do is partition the big one into 2. But the partitioning is not dividing, it's in the power again. So you just got to remember, it's a power thing. It's a power thing. And that's it. So if you remember any formulas, this is the kind of formula you're going to remember. To find the fraction of a year, of a year, you need to take the fraction root. So this is what you do. So try and plug this into your calculator. If you cannot do it, I will show you how to do it. Or maybe I'll just tell you here. So if you don't know how to do it, it's 1.15. You're going to use y to the x. You should have that key on your calculator, and then you put 2 in, but then invert 2. So it's a half, or you can put 0.5 in, that'll do the job. The reason why I'm teaching you this method to an inversion, because we're going to use other fractions, not just an even one that becomes an even number, right? What if we put 1/3? It's not going to be even. It's going to be a repeating decimal, and we can't lose decimals. We have to keep all our decimals until the very end when we summarize our answer, final answer. So in this case, you put 1.15 to the power 2 inverted, and then -1, and equals.
.073.
73? Or
Well,
so?
I rounded up, or is it my bad? 72.4.
Yes, very good. So follow directions on the test of what I want. So I don't know, on this assignment, I may have said 1, 2, 3, 4, 5, 6 decimal places. I'm not sure, but follow the directions. So yeah, he's just to communicate the answer. It's fine. 7.24 would be if rounded to 2 decimal places. So yep, that's what you get. Is there any easy way to do this? This is the easiest I've ever come up with to do conversions. Every time making a statement and converting. Now this is different. This is effective. This is converting effective to effective. This is the technique, okay? For effective to effective conversion. You just have to think of how they relate and then solve that equation for what you want.
Professor, I thought since we are wanting to calculate the semi-annual rate for compounded semi-annually, so I thought that you were supposed to divide by 2 since it is the effective annual interest rate, and I thought that we wanted to have the semi-annual rate, so I thought that was just to divide by 2.
What you
So that-
found, what you
yeah.
found was called not the effective annual, you found the stated rate, or you found the rate. So I'll show you what you found. So this is, let's go back a second. So this is effective to effective. So I knew that I had to go effective to effective because of this. Because this is semi-annual and this is semi-annual. When they match, it means I'm getting another effective rate. When they don't match, so if I'm asked to find, let me do it up here. That's what you found. You found the annual rate compounded semi-annually. You found what I call R 1/2. And all you did was you took the EPR. Let me think for a second here. Yeah, that's the annual rate. So whenever it says annual rate, this is not a stated rate. This is in terms of a year. But the compounding takes place semi-annually. So what you have to do is you have to take the effective annual rate and divide it into, and that's what you got. So you got a different thing. Now let me show you why. Okay, so then this is going to be 7.5. Now you can argue with me that this number 7.5 is very close to 7.24. What's the big deal? Well, the banks seem to think it's a big deal, right? Because in terms of them paying you interest, they're going to, you know, they rather pay you this if they're paying you interest than this amount, right? We need to be clear what rate it is. And in fact, it's the effective rate you get charged. But then why do they use this rate? Why do they say things in terms of stated rates? They say things in terms of stated rates. One second. I think I have to do this again because I am thinking, hold on. 1 second. I don't know why I'm having a moment here. Let me write it down from effective to stated rates or stated to effective rates. So I think I did something backwards. Stated to effective rates. When we go, let me erase this for a moment so I can build that formula. Do that again. So in stated to effective rates, I explained to you that if I want the okay, this is how I'm going to do it. So this is how I explained it to you. If I am given, let's go back to how I explained it to you. So if I'm given R1/2, right? So this would be called the annual rate compounded semi-annually. And I would actually have to, that is determined. And what I did before was incorrect. This is the way I explained it to you. So R1/2 is the annual rate compounded semi-annually. And the relationship to effective rates is that this is stated. And what does it mean to be stated? It means that they took the effective period rate. So let's say you had to pay interest every 6 months on a loan. Or someone had to pay you interest every 6 months on some money you loaned them. So that's like bonds, right? So in bonds, you loan money and you get paid every 6 months in coupons for coupon bonds. So this is 0, this is half a year, and this is 1 year. So this is in terms of years. So the bank or whoever in the financial markets quotes a rate, they're allowed to say the rate as a year. They don't have to mention the half year actual compounding. And they can say it in a very simple way. They can just say the R1/2, the annual rate compounded semi-annually, which is 2 times. So they don't use the compounding. They don't square it up here. They just multiply it. And so when you went ahead and you divided, you assumed that they gave you this, but they didn't give you that. They gave you the effective rate. So if you just multiplied it, so right now we have the equivalent effective rate, right? We had 7.238053. This is the effective rate here. We've calculated it from the information they gave us. So if you compound that, you get 15%. Does everybody agree? That's because that's how I found it. I found it by compounding it. Does everybody agree with that? So if I take this from my calculator and I put 1 plus this 0.07238053, whatever the decimals are, I square that, I will get 15%. And I know that because I got that from doing the reverse operations. What would be the R1/2? Can you guys calculate that for me so we can look at it? So 2 times this number. And then I'm going to tell you why we do this. Okay, we'll talk about why this happens. Or I mean, obviously it happens, we do these conversions because we need the number. We need the number to put in our formulas. That's why we have to convert. Because we have to match the timing of payments with the interest rate. So what I just asked you to do is find for me the R1/2. So I'm doing this because I'm answering a question somebody asked. I'm sorry, I don't know. I think it was Efren. So tell me, so EAR, I want to know this number, but we know EAR was 15 because that's what we used. So it was 15%, which is, so if somebody, let's say somebody made a loan. So somebody borrowed money from you, right? And they borrowed it at 15%. But let's say they came back early rather than a year. So 15% a year, but they came back early. And they're going to pay you interest just for 6 months, and that's it. They're going to pay you back all the money plus interest for only 6 months. This is the question that you're answering when you find EPR1/2. You're indicating how much they actually pay you just for that. And we found out they only have to pay you 7.23. They don't pay you 15 divided by 2, 7.5. They pay you less. You would be cheating them if you make them pay you 7.5. But if they don't know finance, technically, unethically, you could cheat them. Then it wouldn't really matter if these were small amounts. But if you're talking about borrowing $1 million from you, that would add up, right? You'd be taking 0.27% more from them. So my question was, find out what R1/2 is so we can stare at that here. Put everything on the table so we can compare them. So to get that number on my calculator, I'm going to go 1.15 to the power 2 minus 1. And then I am going to multiply it by 2. Okay, so the stated rate, the quoted rate, the rate that just multiplies by 2 is not enough. it's not 15%. Just 1 second. Have a look at that. Are you guys looking still? Are you guys leaving? Are you guys paying attention? I'm gonna do a few more of these.
Used yet.
Okay, are you absorbing that? So the story was, if you make a loan at 15% effective and the person shows up early, you take your money back, plus this is all they have to pay you. 7.238% on every dollar. Not 15 divided by 2. 15 divided by 2 would be 7.5, and it's too high. You can't do that. It's not equivalent. Does that help motivate what the heck we're doing here? So there's different purposes, right? One is to find effective rates from effective rates. Another is to convert from the financial markets that use stated or what's called quoted or nominal rates. Those are all the different words for the same thing. So quoted. I'm touching something here. Quoted or nominal. Now, when I say nominal, it's not the same as the nominal that I mentioned before. It's just a word that they use that captures that it's not effective. These are all the words for not effective rate. Now you can also go effective to stated, which is what we just did. So using the same idea, rather than divide the stated by 2, we have to multiply the effective by 2, the opposite function, to find the equivalent rate. So what you did was take the number you thought was R1/2, I guess, and you divide it by 2. And you thought that you're getting that answer, but that wasn't R1. This is actually EPR1/2. So you misunderstood. All right, so let's go to the next one. So hopefully this captures everything. I put everything on one graph. EPR would be these. EAR is the 15, and R1/2 would be double. But there's also a graph where I give you, so let's do that. Let's do one more graph. Well, not graph, but timeline. So the other timeline would be, oops. Where to move it over? It's giving me a hard time. Okay. If you start if someone gives you R1/2 of 15, is that going to be confusing if I use the same number? So this is what the student did. They thought that was 15. But if that's 15, then you divide by 2, and this is EPR of 7.5. And then finally, EPR or EAR, what would EAR be? So this is a different problem. This is a different problem. That's not the problem that we got, but I'm just showing you what would be the implications of your interpretation. Then you would have to take 1.075. squared minus 1. So in this case, EAR is 15.5625. So you need to learn how to read what exactly you've been given, right? That's the trick. So let's read the next one. The next one was, let me move this over. I'm trying not to show the answer. So the next problem on the list is to calculate the annual rate compounded quarterly. Because annual rate I'll just show you the answer. Annual rate compounded quarterly is actually a stated rate. How do I know that? Because of the way it's said, annual rate compounded every quarter. So that you have to divide that, that's the stated rate. You have to divide it into 4 parts to find the effective equivalent. So that is this scenario, where you just divide it. So this is stated. So why do they do this again? They're allowed to do that. They're allowed to state in terms of simple interest the rate, but the underlying effective rate is actually that divided by 4. So we want to find this. We need to find the effective quarterly rate to actually get this answer in the end. So what is the effective quarterly rate? What should we do to find the effective quarterly rate? Same thing that we did here. Sorry. The same thing that we did up here. Make this chart here. What are you given? What do you need? And then match them in an expression, in an equivalency. So that's what I do below. Given, you're given the effective annual rate. You want the effective quarterly rate. Let me do it step by step. So how did I do it last time? So given EAR, I need the effective quarterly rate. And which one is smaller, the quarterly rate or the annual rate? Which one is smaller? Is anybody there?
Quarterly?
Yep. Quarterly is smaller. And 4 quarters make a year. And the way you always check is like these two should cancel. 1 quarter and 4 make 1. Like when you just visually look, 4 quarters make a year. So a quarter is 3-month period, but we won't get into that. So 4 quarters make a year. So now put in the number that I have. I got 1.15 from the first part. Then I have to partition it into 4 parts, but in the exponent, not divide. -1 equals effective quarterly rate. So what do you get for that? So the drawing, if it helps you, you know, draw these every time until you get the hang of it. You want to partition a 15% effective rate into effective quarterly rate. And again, it could be because someone's borrowing money and they're going to show up 3 months after and give you all your money back, and they just want to pay you the fair interest. What's the fair interest for a quarter? That's what you're trying to solve. What do you get? So to plug this in your calculator, you're going to put 1.15 y to the x. You can use 0.25, or you can do what I suggested before, is put 4 and then invert it and equals. Any takers, any answers? The answer is there as 3.555807. Now, for one period, this seems smaller, right? It's like, because if I just divided 15 by 4, it's 3.75. So this is a little bit smaller. Well, when you compound, compounding is exponential. So by the time we get to the end, it's going to be 15%. 1 plus one of these as a factor to the power of like 1, 2, 3, 4 times, it becomes 15%, because after you're compounding, that really builds. And it's not just multiplication. If you were just to multiply this, which you're going to do next, because that's the question. So we first find the quarterly effective rate, but then so this is the money, this is the amount of interest a person would have to pay you for 1 quarter if they came back early. If we were to state the rate in a document, in a contract, all we have to tell them is the simple interest. We don't have to tell them 15%. We can just tell them 4 times EPR 1 quarter. It looks smaller. It looks, it's suspicious now that you know that it's smaller, but that's how it's done. That is what they're allowed to do. Any questions? Are you with me? Are you guys trying this? I have more pity when you guys try. I don't want to have pity at all, but I do tend to feel more compassion. Let's say that. When you're trying, if you're just giving up, then what can I do? You got to try. I got to say, try. You know? All right, so if you do this by multiplying by 4, it's going to be a smaller number. It's going to be 14.223 and some percent. Okay, that looks weird. I'll just leave it like that. But always follow the instructions about how many decimals to keep. So think about those two. I mean, if it helps you, I'm gonna write this out as a guide. It's basically the answer there. All right, we're going to do continuous compounding if you're ready for it. Or should we do some problems? Other problems. This conversion stuff can get really intense, but this has to be second nature to you before next week. You have to feel very comfortable converting. You have to understand this storyline that I gave here. That should help you. Any comments in the chat? I cannot see it. If you're trying to watch on your phone, this might all be a little bit small. So let me know, I can make things bigger. So this last problem, we went from effective rates into stated rates. I wanted the stated rate, so you had to find the effective rate and convert it. Which effective rate should we use? Well, we should go to the quarterly rate, effective, and multiply it by 4 to get this. All right, question, if you guys want to do continuous compounding or you want to go into doing some of the problems on this document. Or another document. Let me see who's here. Hey, you guys are still here?
Yes, we're here, Professor.
Okay, so what do you think? You want to continue? The same document? I'm waiting for you guys. I'm like checking my Facebook right now. Tell me what you want me to do.
Professor, can you discuss at least more problems from the test prep? You can discuss. Okay, I did number 4, and I have a couple of questions because when I did it, my answer was number A. But apparently, when the answer,
Let's do this
Huh?
one. We can do this one, sure.
yeah, because the thing is that it confused me because you said that when you gave us only the answers for the test prep, I knew that it will be A and B.
Oh,
But
okay.
yeah, I knew that because obviously it will be 3.30, 3.32, etc. I multiplied times 2 because obviously it is compounded per year, and you only wanted if the first one was semi. So when I read the question, it was that answer, but I did it times 2, so it gave me 6.64. But why is E the answer, since I know it's per year effective, but it does not ask you the effective rate?
Okay, so this one, okay, so A is the effective rate. So this one is EPR 1/2.
Are
This,
you typing, Professor? Are you writing
oh,
on your
sorry,
board?
yeah, I'll put it up. Oh, yeah,
Yeah,
I
I
am.
don't-
You can't see? Oh,
No, we can't see.
I have to share, I have to share. I didn't share. I'm just looking at my screen. All right, sharing again. All right, so the first one is EPR 1/2, right? Because per 6-month compounded semi-annual, that's effective. And the compounding frequency is the half part. And then this next one, B, is R 1/2. Because these don't match, but it's per year and it's semi-annual. So I know I use R, and this is the subscript. And this is just this R, the B is 2 times A. So that's good. But you don't have any effective. So you want per year effective. So use this. So what I taught you is to take the effective one and convert it into an annual rate. So you do that with, you remember this. You have to take this one, not multiply by 2. You already did that. You have to compound factors. 1.1 plus EPR 1/2 squared will be 1 plus EAR, which is what E is. Don't forget to take off the 1, right? The 1 is just for each dollar invested, the principal. So try that and you'll get the answer.
Yeah, the thing is that I used my calculator and I multiplied 22 times 12 because it is we want the answer yearly. So they got my monthly. So I did 22 times 12, and then I put it in the calculator. I put the number, which I think it was 264, and my U will be 7.2. My
Oh,
present
you're changing, no, because what you're doing is using so this information here is just going to help you get the first one, right?
Yeah.
But, okay, return the bond sold. So it'll help you get the first one. From the first one, you can get the second one, but you cannot put this information as 22 years in the calculator. It's not going to work because it's not the same thing, because what you will be assuming is that those cash flows are annual and they're not. So that's the mistake. These cash flows, sorry, are annual and they're not. They're semi-annual. So what ties you down, what binds you is the timing of the payments. You can't change that. You can change everything to conform to the timing, you can convert everything to something, but the thing that binds you, what you have to convert it to is the timing of the payments. Once you've done that and you have this rate, you can just use those formulas I gave you to go between the rates, but you can't go back to the problem. All right, so you've done it, you've found this rate, but now all we want you to do is this, to convert it to an effective annual rate. Now, in that sense, this is the effective annual rate, but you can't use it with the information here. It's just going to convey to people, if they want to compare bonds, it'll just say, well, this is what you're making per year. That's all it's going to do. But you can't put that information with this information because the payments are semi-annual and you can't change that. Okay, but that's very good that you asked me that question. It's very good. I hope I explained it. So we're converting it for different purposes, for different audiences, but we cannot change how we calculate the value of the bond. I mean, we can't modify, we can't say that this rate with these coupons is gonna, in 22 years, make this amount. It's not gonna work. So all you're doing is getting a number that people can compare, so they can compare alternative bonds or alternative investments opportunities. So I appreciate the question. So do you get E now if you do that?
I still have my doubts. Can you do the exercise, Professor?
So if you did this up here, so if you did 1063.66 is equal to, so what I have to do is take this number. So I'm really impressed that you got all of that. So it's 7.2. So it's really going to be 0.072 divided by 2 times 1,000 is the payment. So this is the PMT. So it's going to be, what is it? 37. The payment size. 36. Okay, so 36, of course. So it's $36. It's going to be for, so because the payments are semi-annual, it means that you have to convert everything. So first step is always to convert all variables to the timing of payments. So that means there's 44 periods, semi-annual periods. This is the payment. So I'll circle everything we need. So this is 44, 36, 1,000 for the face value, and this is the price. So we put all of that information in the calculator. We start from left to right, we put 44. Interest is what we want to find, we leave it blank. We put in that the price, and I won't bind you. Let's say we are, we purchase this bond, so this is money out, right? So we purchase that bond, and we get $36 and $1,000 at the end. So $36 every semi-annual period for 44 periods. And now we calculate, oops. Sorry, I messed up. Compute that. So that's my rate. So that is the effective semi-annual rate. Then I want the stated rate. This is how they're going to state the yield to maturity on the bond will be 6.645299. Anyway, that will be in the contract or the indenture, the contract for the bond. Now I'm going to divide it again back. So this was the original value. And I also want to know, so I can compare it across different investment opportunities. I want to know in terms of how much do I make a year for every dollar invested every year. This number that you're staring at is how much you make every 6 months. right? But I want to know in compounded terms, how much do I make every year on each dollar invested? So to do that, I have to take this value. I'm going to store it in 1. So I'm going to, well, recall 1. I'm going to divide it by 100 because it needs to be in decimals. I'm going to add 1. I'm going to square it and minus 1. So this is the effective annual rate. This is the number in E. Where's the 1 come from? I don't know where the 1 comes from. Do I have, let me check my decimals. No, I don't have that 1. So see, let's say, so basically my answer was, oh, I lost it, right? So I'm going to recall 1. I'm going to divide it by 100. So this is in decimals, plus 1 squared minus 1. So that's the rate. So it should be E, and I don't know why there's a 1 at the end because I don't have that in my calculator. I have to think about, did I do anything wrong? Let me see, maybe did I miss something when I entered the price? No, I don't think so. Compute price. No, I don't know. But anyway, so the answer is E, but I think it's off a little bit. So if you didn't pick E and you said it was because the 0001, you know, that's why I want you to show your work. So you can say, well, I didn't find that.
Professor, I have a question. Will this type of question will come on the test, or will just be
That is
just
a fair, that's a fair question. That's a fair question. This kind of questions were on the applications page, the one that's called interest rate conversions application. So I think it's fair. Obviously, I didn't have like 20 options, but I had I taught you how to solve those types of problems.
Yeah, I know, but the thing is that we have to choose between multiple answers. Or so yeah, that is the part that confuses me because the last part I didn't know how to calculate it, obviously. So I only got the first 2 answers, which will be A and B. Because obviously, if you calculate it in 6 months semi-annually, you can calculate per year.
Yeah, so this is what I mean. Some questions might have more parts, right? So let's say this question was worth 5 points. All right, so if you did this and you got only 1, that you missed 1, I will give you 4. So you're not going to lose everything, but you get 4 to 5. That's not bad. Or you can argue with me in a nice way, and then maybe I'll give you 4.5, you know. But basically write out everything so I can see what you're working on. So here you would have to write the equation. Well, I didn't finish writing the equation. I just jumped. So that would be bad if you didn't write the equation. So you have to write C1, which was 36 over the interest rate. Not, you don't have to write the thing out with all the decimals, just EPR 1/2. This is a 36. And then it's an annuity. You have to show me, you know, what the calculator is doing. 44 periods. And then don't forget the second part, which is the face value at 44 periods. That's very messy, but let me try that again. All right, so that would be what you would write for me to know what in the world you did. So like I say, if you miss this, then I'd be willing to give you most of the marks, but not all of them. So depending on what you write, I give you 4 out of 5 or 4.5 out of 5. So you're not going to get 0. I mean, in the end, if you actually write the CFA, no one's going to care. But while you're learning, I'm willing to look at, you know, giving you part marks, giving you hope. Should we continue? You want to do another one? Do you still have questions about this one?
I'm good on that one. Thank you, Professor.
Okay, good. Which other one? Should we continue? I have all the answers here. Do you want to do the continuous compounding?
Can you do number 13? I think we had, which is a dividend problem.
13?
Yeah, I think we have to use G star. So can you do number 13?
Another G star? 13?
Yeah.
Okay. Yeah, this one's very complicated. I can do it though. It's good practice. Like I say, this is like just stretching your muscles. I won't ask you to do anything too wild, but you should be able, once you do all the other exercises and you want more practice, these are good for practice. So you didn't get the right answer, but you want to see how close you got, right?
Yes.
Yeah, I'm gonna hang up in Teams. Nobody's come there for a while. All right, so this is gonna be a long one. Hang in there. So let's see, I'm gonna put up another sheet. I'm gonna share. Oh, I don't have the question up. Wait a second. Do that again. There's possibly different ways of doing this, but I'm going to do this the way I have it in my solutions. All right, George Hanton Incorporated. George Hanton Incorporated just paid its last semi-annual dividend 1 month ago. So dividends are semi-annual. So what do you need? To use the formulas, you're going to need the effective semi-annual rate. All right. And any rates and any variables. So step 1 of all these problems is convert to the frequency of the timing of payments. Payments are semi-annual, so you need everything in semi-annual periods. That includes the interest rate, the growth rate, the periods, and What else? That's everything, right? So we have, this is what we want. You expect semi-annual dividends to grow at a constant rate. Notice that I give you a break here, that this is 3% per semi-annum. Semi-annum. So this is already in semi-annual periods. Given the risk of the stock, the effective required expected rate of return is 25.44% per annum. And its current price is this. Okay, so this is what is this number? Let's start there and then we'll work for the other. What does that number represent? Let's draw a picture. Oh my goodness, this is slipping. Okay, so 0. So I can draw this with large tick marks and then semi-annuals here like this. Okay, so 1 month ago, there was a dividend paid. You expect future semi-annual dividends to grow at a constant rate of 30% per semi-annum. Okay, so in a semi-annual period, there's 6, right? 1, 2, 3, 4, 5. That's too small. 1, 2, 3, 4, 5, 6. Get the idea, right? So I'll put it here. And I'll move this one over a little bit. And I'll put one more here. So those marks are months. And I'll make them dark. All right, so this tells me that a month ago, the dividend was paid, and I need that because that's going to help me find the other dividends. There's 3% growth per semi-annum, but because the dividend was a month ago and my timing is here, this is where the price is. The price is right here. All right. But information about the cash flows, the future cash flows, come from a month ago that I have to put into the future. Now, from here to 6 months is over here. So that'll be the next one. So over this period, there should be growth over this period of how much? Again, these are challenging, so just relax and try it. Don't, your life doesn't depend on this. Let's try it so we can learn some things. So from this payment, there's a growth. So this one's going to be higher, the one here. Right? It's 6 months. I'll draw them in and see if I can do it. And if you don't think you're the greatest at math, you can still draw a timeline, right? So work on the timeline and then, or use the timeline and then work on the math part because the timelines are easy. And if the timeline's wrong, I'll look at your timeline and I'll consider it. You know, why did you get it wrong? Okay, so there's my sketch, my timeline. So from here to here, what's the new dividend? What would it be? Just throw it out there. It grows. Because in here, we are told there is a G of 3%. From the last one to the next one. Did you get that part so far? We don't know how to calculate it yet. We're going to try and find what that dividend was. And this is it here. Now, because our formulas only give us the price one period before, the best thing I can do with matching is to take the price minus 1 month ago. Or minus 1 month. And that price should be equal to C1 over I minus G. And C1 is this dividend times 1 plus G, which is, I already know what that is. That's 3%. And then I minus 3%. So I know okay, let's see if we can. What is I? I has to be what? The dividends are semi-annual, so the I has to be a semi-annual rate. So I have to put in here the semi-annual rate because timing of payments is semi-annual. So I need that. I don't know the price last period. I mean, I know the price now. What would be the price last period if this is the price now? That's just a basic time value of money problem. I don't want to give it away. Tell me what to do. Or give me some suggestions. What am I missing? Let me highlight what we're missing. So this one we need to calculate, but we can do that. That's not scary. Let me put a different color because that's not hard. We'll use yellow for not hard or green. None of this is really hard, but I mean, We can find that. We need to find the dividend is the final answer. And again, this is not hard to find. So I'll write this as not 1, but I'll say it's this amount is at 5 months. It's not exactly 1, but for the formula's sake, it would have been. This is supposed to be a subscript. So let me try again. 5. Oops. Okay, you watching me? I'll just give it to you. So this is the effective annual rate that is supposed to be the required rate of return for the problem. So that's the opportunity cost of investing. So that'll be the price of deferring consumption today. Okay, so this is the interest rate, in other words, 25.44 per year, and it's in effective terms, so it's EAR. So we need to convert that. First, we're going to find EPR 1/2, and we'll leave it over here in our legend. So we need EPR 1/2. We have the effective annual rate, and we have to think which one is smaller, the semi-annual rate or the annual rate.
Semi-annual rate.
Right, and 2 small ones make 1 big one, and they're equal to each other. So I'm going to put the number I have, 1.2544 is the rate I have, and I need to partition that in the powers to convert it to the equivalent semi-annual rate. So that number is what I'm going to store in my calculator. Okay, so I'm going to store that because I don't want to lose any of the decimal places. And for all these problems, you need to store all the decimal places. So I'm going to take 1.2544 to the power 0.5 minus 1. And oh, look at that. Very nice. It rounds up. 1.2554 to the 0.5 equals minus 1. No, that didn't work as nice. I don't know what happened last time. 0.2544. I must have typed it wrong. To the power. I'll do it on the calculator so you can see what I'm doing. 1.2544 to the power 0.5 equals minus 1 equals, well, it is, I did it right that time. Right? Again. 1.2544 to the power 0.5 equals minus 1. So it's equivalent to 12%. Well, that's nice and round. And I can copy that out for my formulas. So that gives me that. This is what I want in the end, but I still need this number to make the match. So what is the price 1 month ago? How will I figure that out? I need to take this amount here and discount 1 month, but I don't have a monthly discount rate, so I got to find another rate. So this is usually where students mess up or they go wrong, is that they think they're done. And there may be multiple parts to a problem, and you have to realize that. So I encourage you not to give up. So we need to find the semi-annual rate. Sorry, not just the semi-annual rate. We need to find the monthly rate. And we know how to do that. Let me make some room for myself. Same idea, same relationships, same concept. I write these down, EAR and EPR 1/2. Not 1/2. I want 1/12. So which one is smaller, the monthly rate or the annual rate? Which one is smaller, the monthly rate or the annual rate?
Monthly,
Right. And how many of them do we need to make 1 year? 12.
12.
So we have an equation. We can solve it for that monthly rate. So we're going to take 1.2544 to the power 12 minus 1 for the monthly rate. So to put that in our calculator, we do 1.2, why do I forget? 1.2544. Y to the x, 12 inverted, you see, it's a repeating decimal. That's why we want to invert it and save, because your calculator stores more than just the ones on the screen. It stores in memory more than 20 decimal places, okay? So you want that. And then this is the number you get, minus 1. So the monthly rate is that, stored in 2. So I have in 1, I have this number. And I don't need that number. So recall 2, I'm going to store that in 1. This is a little complex. So I've stored it in 1. I'm going to make a note that I store this number in 1. And this number is 0.01906, and you can just put dots. You can round it and put dots, or you can just put it 676 and then dot 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 that you stored it. You store this number in 1. So you don't have to retype it. You have a chance of transcribing error, all sorts of trouble with copying the wrong number out. It's so long. All right, so what are we doing with that number? We are going to match now. 54.06 divided by 1 plus EPR 112 equals div 1.03 EPR 1/2 minus 0.03. All right, so that will get you the answer. But you have to punch everything in properly and keep all your decimal places to get exactly the answer I get. You can simplify a bit by dividing both sides by 1.03. How is that? So it's just a matter of putting this in your calculator. This one simplifies, that makes it easy too. Because that's just 12%, so this is 0.09 on the bottom. I'll try not to use red, I'll use blue. So this is 0.09. And then, so all you really have to do, this is not bad at all, right? Because all it is this is the messy one. Otherwise, if I was to do this, I would do 54.06 divided by 1.03 divided by 0.09 divided by 1 plus EPR 1/12 equals the dividend. And the dividend from 1 month ago, I used that. That's goes without saying. I didn't write all subscripts, but that's the one over here. So I would say put this number in first, then multiply this to multiply this, then invert it and multiply by that. So that's what I'll do. So I'm going to recall 1, add 1, multiply by 0.09, and then multiply. You want to see me do that? So I have that number on the screen, convenient. Store it in 1 instead in case I lose it. I'm going to add 1, going to multiply by 0.09, going to multiply by 1.03, and equals. I invert it and multiply by 54.06, and I'm not sure if I get the same answer. No, that's not possible. What did I do wrong? Okay, so recall 1 plus 1 equals times 0.09 times 1.03 equals, invert it. Yeah, I guess it's that much, but is that correct? Let me see my solutions. I don't think that's the right answer. Something. I did something wrong with the algebra. Let's see. Oh yeah, I put it in the wrong place. This goes up here. Didn't stop me. Now it makes more sense. Okay, so this goes up here, 0.09. And I apologize, 1.03, and then 1 plus EPR. Okay, give you a second to fix that if you're copying. I'll move this over here. So I cross multiplied this up. I'm gonna put that one down to isolate the dividend. And there you go. That will make more sense because that will diminish this amount here on the top. So let's go back. Okay, so skip that. So 54.06 times 0.09 divided by 1.03 equals, and then divide brackets 1 plus recall 1. Anyway, I'm entering it in a weird way. Okay, anyway, you can practice entering it, but the price of the dividend or the value of the dividend was $4.64. So you can see if I give you a problem even half as confusing as this one, as long as you write out what you're doing, I can see where you went wrong. Okay, if you cannot find any of the options, the problems. Do it again, I'll do it a different way. I'll start on the bottom, 1 plus recall 1, the long number, multiplied by 1.03, which was the growth rate, and then invert it and times 0.09 times the price 5406. And I still get the same answer. All right, so many places you could go wrong. I think the main one is realizing that you need a second rate here. So this is a challenging problem. If I give a challenging problem like this, I only give one. The whole test should not be a big, well, at least the first time. It shouldn't be full of challenging problems. Or extremely challenging problems. Do you want me to recap or are you good? I can review. Questions?
No.
Hello? You're okay? No questions? You want me to stop? You want some more? Yeah, we can do another one. So some of the main things to remember: timing of payments guides your solution. Okay, it's going to tell you what rates, what frequency you need your rates in compounding, and then all your variables need to be changed the same period of compounding. It's the same frequency of the periods of compounding. And in this case, we needed two rates. First, this one was for the coming dividends, but a monthly rate was just to tie in the price, to bring it to today. We didn't bother to go too far I didn't need to actually, I could have done this a different way, and I could have brought the price. So what I did was I brought the price back, right, to the price 1 month from now. There's other ways I could have solved this, but I thought this would be the most efficient. Look, I did it without making mistakes. I did it in 3 steps. Lots of parts, but 3 steps. This rule, step 1, and the rule of the valuation, all the formulas value future cash flows starting 1 period from now. Okay, so that's the other catch. I think those are the 3 things to take away from this. To remember that if I use my formula, the one that I know, in this case, the growing perpetuity formula, I have to put the value 1 period from the first cash flow to come. Also that I don't get any past cash flows. That's not in my valuation. I'm using it to calculate the next dividend, but I don't put in this one that I got a month ago. Because I'm thinking of being a prospective investor and possibly buying it and earning future cash flows, future dividends, not the past one. Clearly, the value of it has affected the future ones, but that's not the same thing. That's not the same thing as that saying I have to add this in. I'm not adding it in. I'm using it multiplicatively to calculate the next one coming. So I guess there's like 3 things or 4 things. It's that we have to convert to frequency of the timing of payments. We have to remember all of our formulas, the ones that I've given you are valued 1 period before the first cash flow. This was a little tricky because I'm talking about semi-annual periods. You have to realize that's 6 months, and that puts me here. And then the alternate conversion rates, the interest rate conversion. So I have to go from the effective rate to a semi-annual rate for the dividends and a monthly rate to capture the one a month ago. By using the effective to effective conversion, all those rates are equivalent. I mean, we have a string of equivalencies, right? That 2.5 years make a year, 12 months make a year. That's what's equivalent, not the rates themselves, but that we can match them. All right. Did you enjoy this problem? You should put away the solution and try and solve it again yourself tomorrow or another day. See if you catch yourself making a mistake. So again, these prep questions are meant to just test you because every other problem I give you the answer for. So this really gives you, I give you the solution. I mean, this really gives you a chance to get feedback about whether you can do these on your own, right? I gave you the answers, and if you want this week or the weekend, if you want to know if you got what you did wrong, how you went wrong, contact me, send me a picture of your work, and I will let you know where you went wrong. So you're not alone, okay? I'm close at hand. Text me, keep in touch. And we can meet again if you want on a Monday, like an evening before the test, even Thursday night if you want, but we have to arrange those dates because I have other things to do too. So are we good? Should I say good night or goodbye? Buenas tardes. Buenas.
Professor, can I talk to you when everyone exits the class?
Sure. Anybody else want to talk to me or have questions? You want me to do another problem or are you tired? If you're tired, I understand.
I believe everyone left, so yeah.
Okay. So
Okay, yeah.
I'll stop the
Yeah.
recording. Hold on.